All right, in today's lesson here, we're going to take a look at a system of equations here. This one here, you can see here, we have ourselves three equations, four unknowns. We want to go ahead and solve this. So when you solve the system, no matter what you have, throw it into an augmented matrix. Again, the first column is going to be my w's, x's, y's, and z's. And just copying the coefficients out here, I get 1, 2, 1, 1, and then equals 8. And then continuing this process here, I have 2, 4, 2, 2, and 16. And lastly, 1, negative 1. There is no y here, so you put a 0 in that place, 2, and 4. Okay, now I've converted this to an augmented matrix, making it much easier for me to row reduce and solve this system. Taking a look at here, the first thing I'm going to do is I'm making the observation. I can go ahead and multiply across by a half on row 2 to simplify this. So top row we're not touching, so I'm going to just jot it back down as it is. Bottom row, same idea. And now I'm just cutting these all in half. So this is going to be 1, 2, 1, 1, and 8. Right away when I go to solve this system, if you notice here, let's bring this over here. When you're going to solve this system, it's no different than when you're solving a consistent system. I'm going to let this be my anchor, and I want to make these entries 0. So you go through the same process you would normally do. So in this case here, I'm going to go ahead and take row 2 minus row 1 and row 3 minus row 1 to reduce this. Again, that top row I'm not touching. And I'm sure you can see by now, because that second row is exactly the same, we end up getting zeros all the way across. And subtracting row 3 minus row 1 gives us 0, negative 3, negative 1, 1, and negative 4. The next thing I'm going to do here, I'm going to take row 2, I'm going to interchange that with row 3, and that's the proper notation to do that. So continuing this up here, we get 0, negative 3, negative 1, 1, and negative 4, and then zeros all the way across. So now, if I go to do back substitution here, you'll notice right away, I'll generate an equation that's going to say 0x plus 0y plus, or I should say 0w plus 0x plus 0y plus 0z is 0. You end up having here, I have 4 variables, right? And I only have here 2 equations. So I'm going to have to introduce some parameters here. So I'm going to have to let my variable z be t, where t is any real number at all. It can be anything I want. I'm going to then move on and let y equal s, where s is any parameter, not the same as t. It can be the same, but or can be different. So I have to distinguish that with a different parameter variable. So this becomes any real number s. Now if I go to my next row here, you can see this will generate me an equation. And this equation is negative 3x minus y plus z is negative 4. But as we discussed here, I've changed the y value to anything with an s, and I've changed the z value to anything with a t. And that allows me to isolate here. So I get I should say I get negative 4 plus s minus t. And then dividing across by negative 3, I get 4/3 minus 1/3 s plus 1/3 t. So I end up getting my x value, and I know my z value, and I know my y value. Now I just have to find my w here. So to find your w value, I'm going to go ahead, go to this equation, and unraveling this equation, you get w plus 2 times x. Well, I know my x value is 4/3. I'm going to substitute that in. Minus 1/3 s plus 1/3 t, and then plus, in this case, y, which is s, plus z, which is t, and I'm going to set that equal to 8. So now, if you take a look here, now I'm solving this equation right here. So I'm going to go ahead and distribute the 2. I'm going to get here w plus 8/3 minus 2/3 s plus 2/3 t plus s plus t is 8. And now a matter of collecting like terms. So I've got here collecting up my S's, collecting up my T's, I end up getting here W is going to equal 8 minus 8/3. If I collect up my T's here, you're going to end up getting 1/3 S, and I bring that to the other side to be minus 1/3 S. Collecting up my T's, I'm going to get 5/3 T, and bring that to the other side, you get minus 5/3 T. And then lastly, collecting up our values here for W, end up getting here, this will be 16/3. If you take 8 minus 8/3, again, getting a common denominator, on that you'll get 16/3 minus 1/3s minus 5/3t. And this becomes my W value. Let's go ahead and put this all together and represent it in terms of a point and its direction vectors. So putting this all together here, if I want to represent the point W, X, Y, and Z, it's going to be composed of the point. So the point is 16/3, 4/3, 0, and 0, plus my first direction vector is S. Now, if I copy this out, we're going to get minus 1/3, minus 1/3, 1, 0, plus some multiple of my next direction vector, which is minus 5/3, 1/3, 0, and 1. Again, when you're taking your direction vectors, you can choose any multiple of that direction vector would also suffice. Like, you don't have to have your direction vectors having fractals because it's any multiple of that direction vector. So I'm going to take this answer that we have here, and I'm going to take my answer, in this case W, X, Y, and Z. It's going to be composed of the point, which you can't take a multiple of the point. The point is stuck. It's going to, in this case, have to be a fraction. But now I'm going to take my direction vector for S, multiply across by -3, and that'll clean that up. So the direction vector becomes 1, 1, -3, and 0, plus my direction vector T, I'll multiply across by 3. I'm going to get -5, 1, 0, 5. And again, what we have here, this is your infinite solution for the intersection of those 4 equations that we initially had, consisting of this point and then any multiple of this direction vector plus any multiple of this direction vector here. Again, keep in mind your S and T values are any real number. Thank you.